Hello everyone, this is Sandhya Gupta, Senior Technical Marketing Engineer for DNS Security. Today we'll be going over Advanced DNS Hijacking demo. Let's first try to understand what is DNS hijacking. So DNS hijacking is a technique leveraged by the attackers to launch malicious activities with legitimate domains by directly manipulating their DNS responses. Once attackers gain the ability to resolve DNS responses to IP addresses controlled by them, they then redirect the users to malicious sites which are then used for launching additional attacks. Attackers can use various DNS hijacking techniques to modify the DNS responses. They could compromise a DNS registrar account or authoritative name server either by exploiting vulnerabilities or through unauthorized access. Then there is man-in-the-middle kind of attacks where attackers positions themselves between a user and a DNS server, intercepting communication and manipulating the DNS responses, leading to DNS cache poisoning, DNS injection, DNS spoofing kind of attacks. Here is an example of a user trying to reach out to a legitimate site websecuritycorp.com. Here the attackers compromise the DNS server for WebSecurity Corp and modifies the DNS record to point to a malicious IP address. By sending these modified DNS responses to a user, attackers then are able to transparently redirect the user to a spoof website for phishing or malware. Now that we know what is DNS hijacking, let's look into the demo and understand how we protect against it. So the setup consists of two mobile users, Mark and Amy. Mark represents the user without advanced DNS security and is not behind Palo Alto Network's next-gen firewall. Amy, on the other hand, is the protected user behind our firewall with advanced DNS security subscription launched as part of PanOS Quasar release. For the demo, we have registered a domain called as websecuritycorp.com and set up an authoritative name server for it. Now let's say an attacker has either compromised the registrar account or is using man-in-the-middle to modify the DNS response. To simulate this environment, we have added a Code DNS, which is an open source DNS server and acts as a DNS proxy between the client and the public DNS server. When the hijacker plugin is not running, then the DNS request for the WebSecurity Corp is directly forwarded to the public DNS server where it gets resolved to a benign IP and the response is sent back to the user. But if the hijacker plugin is running, then it mimics the hijacking scenario and maps the domain websecuritycorp.com to a malicious IP address, and then that request is sent back to the client. Now this modified response will reach Mark, which is not protected behind our firewall, but in case of Amy, which is behind our next-gen firewall, you will see that we are able to detect this modified response and block it immediately. Now let's go to the actual demo setup and test it out. Let's connect to the DNS proxy machine and turn on the DNS core server without the hijacker plugin. With this, all the requests coming from the client machine will be forwarded to Google's public DNS server. Now let's connect to our client machines. Now here are our two client machines. The first one is that of Mark, which is not protected by our next-gen firewall. Whereas this is Amy's Windows machine, which is sitting behind our next-gen firewall and protected by advanced DNS security subscription. Now let's use a web browser to reach out to WebSecurity Corp. Here a local newspaper web page is loaded. Let's also do a quick NS lookup to see the IP address that this domain is getting mapped to. Here you can see that the domain goes through our DNS proxy server out to the public DNS server and resolves to this benign IP address. Now let's repeat the same thing for Amy's client machine. We'll connect to the web browser, Here you can see that the same web page gets loaded. Let's do a quick check for the NS lookup as well. Here you can see that the domain Web Security Corp resolves to the same benign IP address. So everything is looking good so far. Now let's go back to our DNS proxy machine and turn on the DNS hijacking plugin. So here we'll first stop the existing DNS proxy server and then we'll start the hijacker plugin. So what it does is that when any request for websecuritycorp.com comes, it modifies the DNS response to point to this hijacker controlled IP address. Now with this done, let's go back to our client machines. Let's do a quick NS lookup to see the domain to IP mapping. Here you can see that the response that this client machine is getting is that of the attacker controlled IP address. Now if we go back to our browser machine and reload this page, here you can see that the IP of this benign domain is compromised. So attackers present a phishing page controlled by them. The users get presented with the Office 365 login page, which looks benign. Users enter their credentials, which are now in the hands of the attackers. Now let's switch to Amy's client machine, which is behind our next-gen firewall. Let's do the same thing. Here you can see that the compromised websecuritycorp.com response is getting blocked by our firewall and the resolution is not getting sent to the client. If we reload the page here, you can see that our next-gen firewall has blocked access to this particular domain. Now let's go to our next-gen firewall to see the threat logs. Here you can see that the Advanced DNS Security Service has detected a DNS hijacking attempt and successfully blocked the domain. You can see that the application data type is DNS and the action is sinkhole. Now let's open the detailed view. Here you will see the ID associated with this threat, and if you open this up in the threat vault, you can see that it is being detected by our real-time DNS hijacking detector. So this concludes our demo. Hope you enjoyed watching it. Thank you so much.